Muted. Straight. Okay. Yeah,
A very good morning to our honorable guests, brilliant researchers, and wonderful participants gathered here today. I, Astitwa Bisht, with co-anchor Akshita Tiwari, are delighted to be your host for day two of this conference.
It is a truly honor to welcome everyone as we embark on the second day of International Conference on Emerging Application of Artificial Intelligence, Machine Learning and Cybersecurity 2026. A remarkable platform where visionary thinkers, cutting edge researchers, and transformative ideas come together under one roof.
To set the tone for today's proceeding, I would like to begin with a thought that speaks to the very heart what drives us forward. Innovation is the ability to see the change as an opportunity, not a threat. Seated among us today are some of the finest academic minds, seasoned profession from the industry, and influential leaders whose work continue to redefine the boundaries and shape the world we live in.
We now have the great honor of introducing a distinguished personality who has made remarkable contribution at the intersection of artificial intelligence, machine learning, and product management. Mr. Anmol Agrawal, sir, Technical Product Manager at Intuit TurboTax, San Francisco, and a proud animalist of the University of California, Berkeley, and UC San Diego.
Mr. Anmol Agarwal sir's academic journey is as impressive as his professional one. He holds a Bachelor of Engineering in Computer Science from Guru Gobind Singh Indraprastha University, a Master of Science in AI and Machine Learning from UC San Diego, and an MBA from the Haas School of Business at UC Berkeley, where he was the sole recipient of the prestigious Student Always Award for exceptional leadership. Most recently, he has earned a certificate in agentic AI from Johns Hopkins University in 2026.
What truly sets Mr. Anmol Agrawal sir apart is his rare ability to bridge deep technical expertise with strategic product thinking. At Intuit, he has driven an $8 million revenue increase by deploying ML-based recommender system, build RAG-powered cementing searches using cutting-edge language model embeddings, and resolve critical data pipeline challenges impacting over 50 million users. His prior tenure at Uber spanned both software engineering and product leadership, where he launched dynamic pricing algorithm across 900 cities globally and led initiatives generating over $100 million in incremental annual bookings. We consider it a great privilege to have him deliver the keynote speaker address today. And we are certain his words will inspire every researcher and innovator in this room.
We now request everyone to warmly present Mr. Anmol Agarwal sir, who is virtually present with us.
Thanks, everyone, and I can get started with my talk. Let me just share my screen. Are you able to look at my screen?
Yes,
Okay.
it is visible.
Sounds good. So I'll get started. So first of all, good morning, everyone, and thank you, Dr. Hassan and the ICE AMC team for having me. It's an honor to open day two. A bit about me. I'm a senior IEEE member, and I've been working on AI-driven personalization and pricing systems for over a decade. Over the past few years, I have published several papers on pre-live evaluation, fairness-aware decisioning, and explainable demand forecasting. And I run A/B test and personalization for a living. So this talk sits at the intersection of practice and research. And that's what I thought will be the most valuable for this conference. So this talk sits at the intersection of practice and research, and the lens I'm bringing in today is that did experiment B beat experiment A, but which users benefited, why, and what should we learn next? So the topic of my talk is experimentation in the Gen AI era, which we know is absolutely changing how we think about most of machine learning, most of artificial intelligence, and that is quickly and rapidly changing how experimentation happens. In the next 20-25 minutes, I will try to take you on the journey that what Gen AI can do you for your experimentation as you do your work as researchers, as student authors, or as professors, and also show what industry is doing for the same. So a quick scenario, you're testing a 10% price increase on a premium plan. You run an A/B test, and 2 weeks later, the results come back. Variant B, which lifts revenue per user by 8% with a p-value of, let's say, 0.04 and confidence interval between 3 and 13%. So what do we do now? That's the main question that your advisor or your manager would ask. And are users happy? Will any of them churn 3 months from now? And you don't really know. You can guess, but you can't say your guesses. And for the last 20 years, this has been the deal with A/B testing. It tells you what won, but it does not tell you why. And my argument today is that it is changing. Generative AI does not replace A/B testing, it adds a reasoning layer around it. What to test, who may respond differently, why a result happened, and what the organization should learn next. You are no longer just responsible for the lift, you are responsible for the explanation. And just to connect dots with the conference, yesterday I was listening through multiple papers that the students were presenting, and all I was thinking about is that every paper had some form of A/B testing or some form of testing, and how could that testing be done even quicker and even faster. So this talk will help you today in that. So over the next 22 minutes, I will walk you through 5 concrete shifts in how this is being done. I'll try to include one short demo, and we'll have a few open questions at the end if the time permits. So stage 1, hypothesis generation. This is the very first thing you do when you sit down to plan an experiment, either with your professors or your managers, or when you are making those decisions in the product. And here's what it looks like in most teams today. You are in a room, a senior researcher, maybe a designer, a data scientist, an engineer, a fourth-year student, a first-year student, and someone says that, I think users would convert better if the CTA was green. Or someone else says, actually, I think shortening the form can help more. You write down 5 ideas on whiteboard and you vote. You pick one and you go run A/B test. Now, here's the uncomfortable part. Booking.com has published this number multiple times that 9 out of 10 test ideas tested at Booking.com either don't work or actually negatively hurt. That's 9 out of 10, almost 90%. And these are the people who do experimentation for a living. The reason isn't that the team is bad. It's that the hypothesis generation process is structurally limited. You are working from institution, you are working from what's in the room, and you're ignoring the enormous amount of data that's already sitting in your system. They could be support tickets, product reviews, session recordings, customer feedback, because reading all of them definitely takes time and nobody has weeks. So that is what is changing with Gen AI. You can now point a large language model at 6 months of support tickets and ask, what problem do users keep complaining about that we haven't addressed yet? You get a ranked list of candidate hypotheses, each grounded in actual user language with examples, and that's just 10 minutes of work. What's actually new here is that LLMs are smart. It's just that they are taking so much of unstructured signals and are able to give us some structured information at scale. So let me show you how this will look like in practice. Imagine a pricing team, and they want to know what's the reason behind the churn after a recent price increase. The old way, where one person would say that maybe the hike itself was too steep, maybe the market was not ready for that price increase. But the new way is that you feed your last quarter of cancellation notes, your billing tickets, your exit service to an LLM, and you get back 5 specific friction points. It could be that no clear value reason was given, monthly users were hit harder than annual ones, and henceforth. So now the honest catch is that LLMs over-index, and this is what we need to watch out, that LLMs over-index on what's frequent in the data, not what's important. If 90% of the data that you're providing is all about login issues, then the LLM will hand you 10 login hypotheses and miss the one revenue-related hypothesis that's actually important. So the key takeaway from stage 1 is that hypothesis generation has stopped being limited by who's in the room. Your unstructured data is now the room, but the judgment about what matters still relies on the humans, still relies on you. So just to connect it to a paper writing of how you're writing a paper, you have one hypothesis, but what you can do is work with LLM to use that hypothesis and ask it to think about 10 different hypotheses. And what it's doing, it's just expanding the way you can think about a problem. It's giving more horizon, more substance to the problem, and that's how you can use it in your day-to-day research. Moving to next, which is the pre-live evaluation. So here's the problem with how teams have always tested ideas. To know if an idea works, you need real users. And to get real users, you need live traffic. And if your product is low traffic, such as maybe a B2B tool with few hundred enterprise customers, or if the flow is very sensitive, such as your pricing, your support, your fraud, you basically can't run a clean A/B test. The risk is too high or the sample size is too small for it. So with GenAI, what's changing is that now you can build synthetic personas and run your variant against them before any real user touches it. And these personas are not just name and a demographic, it's the behavioral specification. It depends on what past actions have been taken, what intent signals, and what common friction points did the people see. And so based on these personas, you can show it variant 1 or variant 2, and or maybe like 10 variants as of now, and kill few of them immediately. And this will save you many weeks of live traffic. So just to show a little live demo, this is what it looks like in practice. I hope it's visible. I know it's a little. So what I have written is a prompt, and this prompt is in Claude. So what we are trying to do is we are telling the model, or we are telling the LLM model over here that, hey, that ground yourself in the real data and not abstract context. So we are trying to reduce the context window of an LLM. And we are giving it some context. We are telling it about what the product is, what a baseline is, what happened with the previous test, what are the issues that we saw last year, like got too expensive, found a cheaper alternative, was just trying it out. And then we also give it what experiment are we trying to evaluate. Like, for example, a control or a treatment. So such as control can be whatever the current price is, and B, which is the treatment, is basically the price increase that we are trying to do. The step 2 we have to do is we have to tell it what are the different personas that we should create about. So we just can't go to LLM and say, hey, create 100 people out of the data that we have. We have to give it some personas. It can be some segments that you're trying to treat. It can be some user groups that you're trying to work for. So in this, like if we just tell it about the renew, churn, downgrade, like these are like the different, and then we need like what has been the treatment effect. Step 3 is about like how we aggregate and make a decision about it. And so for example, like what is the revenue lift? What is the 90-day churn delta that you're thinking about? And then we want to do calibrate, and then and that's where we stop. So step 5 is all about is for helping you researchers that you can adapt to it to your domain. So the pricing test that I just talked about can be your hypothesis that you are trying to resolve in your research paper. The variant A and B can be your baseline versus ablation studies that you generally do. And then your reasons can be the domain reasons that you think are important for the paper or for the testing that you are doing, and henceforth. So if we go over this and we just provide this prompt to Claude right now, so what it does, it's trying to create different personas. So for persona 1, it created, this is a power user. It had 2+ tenure and annual plan. And based on that, it is trying to like mirror and mimic the different variants that it wants to show. And then it also shows about like what is the expected revenue lift that it is thinking about, what is the 90-day churn, and then how should we think about decision. It's also created some calibrated queries that once the data comes in, then how do you think about it? So, so you just saw that the model take a behavioral spec and walk through a simulated pricing. Now, what you just saw is a toy version. Paste a prompt and get an output. In real production, this becomes a system. Recently, I wrote a paper for, it's called GTSO, and I can share the link later. What I did was I took years of behavioral data around like how the shoppers behave when they're going and buying on an e-commerce website, and ran counterfactual replay on every variant before launch. And for the output, I used causal uplift estimates and built in some of the fairness audits. So I did the same 5 steps, but at a production grade, ran it for 100,000 customers, and I can share my paper later on. So now the catch is that synthetic users, it seems very easy to build. It seems very quick to build, and we all might think that it will solve all the problems. But that's where the mess is, because models carry biases. And if the model is only seeing one kind of user, the synthetic users will also be those kind of users. And that's not where a proper A/B testing can really help. So stage 2 lets us know which ideas are worth running live. But once we do run the live test, And when the test results come back, we want to know more than the average lift. We want to know who was helped and who was hurt. And that's the next stage. So in cohort discovery, your test is running live, or it has just finished, the results came back. So now your manager, your advisor, or your professor is asking you, but what does it mean? What actually happened? And the way teams have been answering this question is like, before you launch, you create certain segments, you define those, and you basically tell that, hey, I want to run a test for this particular segment. It can be based on the device type, geography, customer tenure, plant tier. And after the test, you try to look at each segment, each slice, like what that lift has been. The problem with that approach is that you can only see the segments you thought to pre-register. But if the real driver of the lift is something you didn't put on your list, let's say users who opened Help Center, then whatever you have been doing will miss it, and the results will not be good. So what's changing is that LLMs can now cluster users by their latent behavior patterns. It can think about what are the sequence of clicks, what are the dwelling times, and what are the intent signals that these customers are doing. And the model reads the actual behavior data and tells you something like, hey, Variant B helped users who started their session by tapping the help icon. And that's where is the real insight, and that's what can be used in research and in product and in technology itself, or in tech companies itself. But the catch is that model discovered segments are not facts. As we said that, just like hypotheses and other stages, we know that it has some biases. So you need to validate them. So once the model tells you like, hey, these are the different segments that you can think about, you need to go back and look at your data and think about, is this behavior pattern hold up when you rerun the test, or is it on a different window? Is there any of causality over there? So to watch out, the fairness implication of who helps whom are themselves a publication area. A winning area can still be a bad decision if the lift's average conversion is high, but it hurts a vulnerable cohort. So I have also published some papers on this area, which is about like how the fairness aware pricing should be. Like you just cannot reject one part of the society just because we think that the money is not coming in or what is happening. So stage 3 lets us see who has helped and who was hurt, but the harder question is why. And that's where we move next. So when you run the test, it's one thing to talk, like after this talk, if there's one thing that you should take home, it's about this stage, that why something happened, why a variant A worked, why variant B worked, and what exactly did the customers learn. So for the past 20 years, this is what happened after every A/B test concluded. Some analysts would download tons of data and will run queries and give you some text around that, hey, what happened? But with Gen AI, that is changing. What you can do is you can take all the data that you have run, all the A/B tests from customer signals, behavior, and ask Gen AI to think about what exactly does it think is the reasoning behind whatever has happened. So now the cost of defensible written explanation has gone from 3 days of analyst time to just seconds and a prompt. And that's not small. That's a categorical change that we are seeing in the industry right now. So now, and this is the most important catch in the entire talk, that a confident hallucinated why is worse than no why. So even when you are doing your own research in your papers, my suggestion would be that recheck every statement that you're asking LLMs to write. Recheck every reasoning, every context that LLM is doing, because once LLM starts thinking that what it is saying is correct, there is no turning back, because it will try to convince you that whatever it is saying is correct. So you need to just keep checking again and again, because these models are trained to give a confident sounding wrong answer, And the team will believe it because it will produce data that really does not exist. And once this becomes routine, and once this things happen, that we are not looking at the real data, we are not talking about free association, that's when things go really bad because you will start going in a direction that's not correct. So stage 4 changes what an experiment produces. The output is not just a number, it's a number plus a defensible story. And just think about it as the results section of the papers that the students were working on. You ask about like, hey, this is what we did with my experimentation. These are the inputs, these are the outputs. What do you think are the results? But do get it verified by some senior researcher, by other professors, so that you have more confidence in what LLMs are producing. But it definitely reduces the effort and improves the quality of the words and the way we write. Moving forward, stage 5, which is about cross-experiment learning. So far we have just talked about GenAI does for one experiment, but now think about what it can do for a team or for an institute like yours, where you can think about every professor is doing multiple experiments, every student is doing multiple experiments, and they all learn from each other. So today, what's changing today is that you can put your past experiments, which is the metadata, the results, the narrative wise, we just talked about previously, into what's called a RAG store. And RAG stands for Retrieval Augmented Generation. It will be a store from all the previous data and information that your team or your college has collected together. And when a new hypothesis comes, you will automatically try to first look at what are the previous experiments that ran, what are the previous research papers that was produced out of this university or whatever data source you are using, and that will reduce the hypothesis that you are generating. It will actually sharpen the hypothesis that you are generating. So the catch over here is very simple, that if it's garbage in, then there will be garbage out. So if your past experiments were poorly logged, they did have vague hypotheses, they did not have narrative wise or had unclear results, the memory is kind of poison. Think about RAG as just memory that's helping LLMs to basically understand and give you better answers. And just think about it as a memory. So if we will have bad memory or like wrong memory, then the results that you will get is exactly going to be the same. So stage 5, which is the stage, only works if stages 1 through 4 are working. So for the cultural shift, what we are seeing is that experimentation stops being a series of one-shot experiments, but it becomes a learning system. And that's where the speed of experimentation also increases. So before I close, there are 4 challenges to keep in mind anytime you put GenAI into your experimentation workflow. First is causal rigor. There is no other way of using randomization power guardrails. Like GenAI can definitely help you, but it cannot manufacture causal validity. And if you're not randomizing, you are not running an experiment. Use it as a quick way of generating some hypothesis, validating it, removing the worst variants, but you need to still run experimentation to produce the causal rigor. The biases is a big problem. Like we know that LLMs inherit historical biases because they're trained on the data that we have put into them. And the synthetic personas may quietly miss the minorities you most need to design for. And similarly, privacy. Anonymize what you send, aggregate before prompting, and prefer on-prem models for sensitive flows. And trust is definitely a big issue over here, where a hallucinated Y is worse than no Y, as I just explained. So if you have to take one screenshot today, so this is, I would say, is the most actionable plan for all the researchers and students. So an LLM can propose your next ML ablation study, given whatever your results are. It can generate synthetic users for, let's say, some of the HCI pilots or UX pilots that you are doing. It can help you build a RAG store so that you can learn and cross-pollinate in terms of knowledge. And then, and then, however, there are some limitations, and the limitations are about that the LLM can draft your limitation section, but still it will not really show any limitations. So that thing needs to be really taken care for. So the three takeaway things to today from this talk is that one, the why is now unstable. Two, trust is bottleneck. It's not a capability, and don't treat it like a capability. With working with LLMs, you need more trust with them. You need to give it better context. You need to recheck your work again and again, even more than what you have done previously. And third, I would suggest is that pick one stage of the paper that you have been doing and try it this week, and which can be the hypothesis, evaluation, cohorting, narrative, or even just writing the final results section for your test. So that's all from me. That's my email ID, and that's my LinkedIn profile, my last name. And happy to connect with any researcher, any student who wants to work into this space and have some ideas or need some clarification or discussions. I'm open for any questions.
If anyone have any questions, they can ask.
A heartfelt thank you to Mr. Anmol Agrawal, sir, for such an enriching and stimulating address. The insights and the perspective you have shared today will undoubtedly resonate with all of us long after this conference concludes. We are truly grateful for your time and wisdom, sir.
Thank you.